The baby appears to be floating away. Psych, it's just a prank. But that got me wondering how many balloons would it actually take to start lifting a baby. There's the buoyant force of the balloons and the baby, and then there's the weight of both too. We will solve for n number of balloons, and I'll add one because a baby displaces roughly the volume of air that a balloon does, and this just makes it easier. Anyway, using Newton's second law, we sum the forces and we want to find the point where we have just enough balloons to slowly lift the baby. And this tipping point is when the acceleration is 0. Any amount greater than this will lift the baby, so now let's sum the forces. The buoyant force only depends on the amount of air that's being displaced, so we use the density of air times the acceleration due to gravity times the volume of air that's being displaced, and we're doing this for one balloon and then multiplying it by the number n. The first weight is the weight of the helium in the balloons, and weight is the mass times the acceleration due to gravity, where the mass can be calculated by multiplying the density of helium times the volume of helium in the balloon. Lastly, the weight of the baby is just the mass of the baby times the acceleration due to gravity, where the average baby weighs around 3.5 kilograms. Now I'm going to plug in the symbolic variables for each of these forces we just discussed, then I'll plug in the values, check for units, and solve for n. While I do that, I wanted to tell you to stop buying helium balloons, not because they are dangerous for babies, but because we're actually running out of it on Earth. Helium is so light that it just floats straight into outer space. It's probably hypocritical for me to say because I might need to buy helium for future demos, but buying it for birthdays is just a total waste. Anyway, solving for n, we get that you need at least 333